All right, hello everybody. Welcome to 6.4, our final section of Unit 6. We're going to talk about Venn diagrams and GCF today. Um, GCF is something we should know how to do already. We've done GCF in Algebra 1, Algebra 2, probably in geometry at some point as well. But it's the Venn diagram focus that we're really wanting to hone in on. It's using Venn diagrams uh, to create the GCFs. So the GCFs is just sort of our tool to really look more at the Venn diagram aspect of it. But let's get into it, right? So what are prime factors? Well, prime factors are prime numbers that multiply together to make whatever value you have. So like let's look at an example for numbers 20 and 30. What are the prime factors of 20 and 30? The way I like to do this is I usually like to make a factoring tree. So 20, think of any two numbers that multiply to 20. It can be 2 and 10. It can be 4 and 5, whatever you want, right? I'm going to think of 4 and 5. Now, 4 is not a prime number. 4 can be broken down even further. I can divide 4 by 2 and 2. Right? Now, 5, on the other hand, is a prime factor. So 5 is a prime factor. It can't be broken down to any other branches. And this 2 are both prime factors. They can't be broken down to any other branches either. So the prime factors of 20 are 2, 2, and 5. And if you multiplied those together, you would get 20. 2 times 2 times 5 does equal 20. So it's like breaking 20 down to its most uh, tiniest pieces, right, that make up 20. The prime factors that make up 20. If we look at 30, similarly, you can think of any two numbers that multiply to 30. We'll go with 5 and 6. Now, 5, again, is a prime number. 5 can't be broken down to anything other than itself in 1. So 5 is a prime number. 6 can be broken down, however, to 2 times 3. Right? 2 times 3 makes that 6. So, and 2 and 3 are again both prime numbers. So the prime factors there are 2, 3, and 5, right? 2 times 3 times 5 should make 30. Now, what we're looking for here, oh, by the way, before I carry on, let me just point out, even if you choose a different set of numbers, like for example, let's say you, instead of choosing 5 and 6, you chose 3 and 10. You'll still get the same prime factors. 3 is a prime number, and then 10 breaks down into 2 and 5. And so either way, you still get 2, 3, and 5 as the prime numbers. So don't worry about which numbers you divide by, because at the end of the day, you should get the same prime factors. All right, so now we're going to make the Venn diagram. So what I want you to do is look at the list of prime factors that we made and find common factor between 20 and 30. So for example, you have the 2's are common factors and the 5's are common factors. We're going to put the 2 and the 5 that they share together in here. So let's make 20 the left side, 30 the right side. So they both have 2 and 5 as prime factors. So that goes in the middle. And then this 2 is left over for the 20, and this 3 is left over for the 30. And that is our GCF tree. So 20, as you can see, has 2, 5, and 2. And 30, as you can see, has 2, 5, and 3, which again are those prime factors for both of them. Right, so that's just making the Venn diagram of it. Now the focus is in the middle. The middle, you'll see again, they have 2 and 5 in common, right? That's what's in the middle. And 2 times 5 makes our GCF of 10. So multiplying these together, that's our greatest common factor, 10. Now, ultimately, most people I could probably ask you from the beginning, say, hey, guys, what's the GCF of 20 and 30? What's the largest factor they have in common? You would say 10 because both numbers can be divided by 10. So again, we should know the GCF is 10 from the beginning. But the real issue here, the real thing that we want to try and do is make the Venn diagram of it so that we kind of get more experience with using these Venn diagrams. All right, so let's do a couple more examples, right? So 66 and 72. Let's look at 66. Now 66 breaks into 11 times 6. 11 is a prime factor. Let me put this, I'm going to make this a different color. 11 is a prime factor. 11 cannot be broken down into any other number. 6, however, can get broken down into a couple numbers. It can be divided into 2 and 3. 2 again and 3 are prime factors. Now let's look at, don't mind my color coding for a minute, I'll explain that later. Let's look at 72. So any two numbers that multiply to 72, let's go with 8 and 9. Now, neither of these are prime factors. 8 can break down into 4 times 2. And even still, the 4 can get broken down into 2 times 2. Now the 9 can also get broken down into 3 times 3, right? Which are, again, both prime factors. All right, you're going to understand my coloring here in a second. Now, if you list them out, right, we have 2, 3, and 11 for 66. We have 2, 3, 2, and 2, and 3 for the 72. You can see all the branches. When the branches ended, I circled the numbers, right? 2, 2, 2, 3, and 3. Now you can probably see why I color coded them the way I did now. Because next thing I'm going to ask is, well, what factors do they have in common? The factors they have in common, they have a pair of 2s and a pair of 3s in common. So that's what's going to be in the middle. Let's go ahead and make sure I label these as well. So this side will be 66, this side will be 72. All right. So so they have the common factors of 2 and 3. Now don't forget there is still the 11 that goes with the 66 side, and there's still the extra 2s and 3s that go with the 72 side. So these are this is the Venn diagram again. You can see 2, 3, and 11 for the 66, and then 2, 3, 2, 2, and 3 for 72. Right? So make the trees, list them out, and then find the pairs that match, put them in the middle, and then any excessive numbers go in the outer part of the circles. So let's try another one. Oh, GCF, by the way, 2 and 3 combine together to make 6. So GCF there is 2 times 3, which is 6. All right, so now let's look at another one, right? I'm just going to keep it all one color here, just so to save time, right? Because it takes a lot of time to kind of change color. So let's start with 225 and its factors. So 225 let's see, it can be broken into, I think, 25 times 9. Okay. Now both of these can break down as well. 25 can break down into 5 and 5, and 9 can break down into 3 and 3. Now those are all prime factors, so that's going to be my 25 broken down. 5, 5, 3, and 3. All right, now let's look at 90. So doing the same thing with 90, I can do 90 with 9 times 10. The 9 can be 3 and 3, and the 10 can be 2 and 5, right? And again, that all finishes the branches. 3 and 3, 2 and 5 are all prime numbers. So we have 3, 3, 2, and 5. I like to list them out because it helps me find pairs. So as you can see, I can see a pair of 3s, another pair of 3s, and a pair of 5s in common. So 3, 3, and 5 is what they have in common. So I'm going to put that all in the middle. This is, let's put 225 on this side and 90 on this side. So you're going to see that the extra ones I have a 5 extra for the 225, and I have a 2 extra for the 90. And so there you go. Again, that's the Venn diagrams. Now in the middle, again, you can see 3, 3, and 5, which if you multiply them together, 3 times 3 is 9. 9 times 5 is 45. So 45 is the GCF, the common factor. Let's look at just 2 more. Let's do 98 and 44. Let me zoom in on this side. So 98. 98 can be 49 times 2. Now 49 is not a prime number. 49 can be divided into 7 and 7. 7 and 7 are prime numbers. So is 2. So 98 is 7, 7, and 2 are its prime factors. Let's look at 44 now. So 44, I can break it into 4 times 11. 11 is a prime number, but 4 is not. So we're going to break 4 down into 2 and 2, which again are both prime numbers. So 44 is 2, 2, and 11. So let's find a common pair. We have a common pair of 2s. So that'll go in the middle. Let's see here. Put 98 on this side and 44 on this side. That's all they have in common though. So you can see there's still the 7s for the 98 side. And there's still the 2 and the 11, the additional 2 and the 11 for the 44. So the GCF is just 2, right? That's the only thing that's there. So GCF is just 2, the number that was in the middle, the one factor they had in common. All right, now let's look at the last one, 146 and 224. So let's see, 146. 146 can be broken into trying to think, 73 times 2. Now, funny enough, 73 is a prime number. It cannot be broken down any further. Neither can 2, of course. So 146 is just going to be the number 73 and 2. A little comma there because 7. I don't want you to think it's 7 and 3. It is literally the number 73. Okay, 73 and 2. Now let's look at 224. So 224 to start with can be trying to think. 56 times 4. 56 times 4. That's one combination. 56 can break down into 7 times 8. 7's a prime factor. 8 can break down into 4 times 2. 2 is a prime factor, and then 4 can break down into 2 times 2. A lot of factors there. We still have the 4 to do as well. 4 can break down into 2 and 2 as well. All right, I like to circle them as well. Makes it easier for me to look at. So overall, we have a 7 and then 1, 2, 3, 4, 5 2s as a factors. 7 and then 5 2s. So what do they have in common? Well, they have a pair of 2s in common. And that's about it. Just a single pair of 2s. So let's see, 146 and then 224. So 146 has the 73 extra, as you can see. And then the 224 has a 7 and then 4 other 2s extra. So 7 and then 4 other 2s. There you go. That's it. And don't mind my typo here. This obviously, these should say, 146 and 224, right? Yeah. And the prime factor there is just 2. 2 is literally the greatest common factor we have for it. All right. Well, that's going to do it for these notes. Hopefully it helps. Again, to summarize it, here's what I would do. Make your factoring trees, right? Make sure you circle the ends of them because it's easier to keep track of that way. And then make the list of the factors and see what's in common and then see what's not in common. And that's how you can fill in the Venn diagram. The common pieces will go in the middle, and then whatever's not in common will go on the outskirts. Okay, that's it. I hope you guys have a good rest of your day, and I'll see you next time on our test review. Bye for now.